Good afternoon, good evening, good morning as per your time zone. I know many of them joined from the various regions. Welcome to the Bella Vista Western Sydney Salesforce Developer Group once again. Thank you for registering and joining the today's session. We have the amazing speaker today, none other than Meera R Nair, with us sharing about the Salesforce DevOps using the GitHub Actions. Let me introduce about myself. I am Shaktivel Madhesh and a senior working with Techforce Services and also a Salesforce MEP and community group leader for the Bella Vista, Western Sydney, Australia. I'm actively available the social channels, so you can reach out to me any of these social handler. And about the agenda, the welcome again once again for everyone. So we actively organizing the events regularly and also posting the group activities in these social channels. Please feel free to follow and join the group and get the up-to-date information, either as event information or any technical information. And Meera will be covering today about the Salesforce DevOps using GitHub Actions. And later I will cover about some news and update announcement. And finally, we are planning to give away a few certification voucher for the random participants. Please fill your information in this link bit.ly/pvvoucher27. I will pass it to you in the chat window. Without further delay, I hand over to Meera. Meera, you can introduce about yourself and then you can start your session. I'm stop sharing.
Sure, Shaktivel. Thank you so much. Just for the introduction part, I will switch on my video, and probably after that I will switch off so that I can, there won't be any connectivity issues. And once again, thank you so much, Shaktivel, for having me today. And thank you for all the great work that you are doing to the community, all those knowledge sharing, your YouTube channel. And I'm always seeing like you are always sharing anything that you are getting to everyone in the community. So many times I'm also getting very much knowledge about whatever you are sharing. So thank you so much for that. And
thanks Meera.
Yeah. And yeah, a little about myself. I'm currently working as a Salesforce architect at UST. Having around 15 years of IT experience, in which 13 is in Salesforce platform itself. And I have around 19 certifications. I am leading Trivandrum Architect Community Group also. And I'm a 2-time Salesforce MVP. That's about me. So let me start sharing my screen, and Shakti will please confirm once you are able to see my screen.
Yes, I can see your screen. Yeah.
Okay. So, like Shaktivel mentioned, today I am going to talk about Salesforce DevOps using GitHub Actions. I thought of starting with this session because in our recent project, we are implementing DevOps using GitHub Actions. I thought it is a good idea for me to share all the knowledge that we gained, the advantages of GitHub Actions, some of the considerations you need to really consider before making a decision of making or utilizing GitHub Actions as your DevOps solution. So we are going to cover all these things in our today's session, and I will try to demo a small part of GitHub Action implementation, a simple use case or simple DevOps flow within Salesforce using GitHub Actions. So what is DevOps? I hope you all are using some kind of tool to implement DevOps. You might not be part of the actual DevOps implementation, but at least in your project, you will be using DevOps for all your deployment and the continuous integration and continuous delivery purpose. So basically, DevOps is a set of tools or practices that we follow in our development life cycle to complete our development process, which includes the deployment till the production. So while I'm going through the details, it will be good to hear from you, like, what kind of different tools you people are using for the DevOps purpose. You can share in the chat and I will take a look at that later. So we are going to see some basic components of DevOps. I'm not going to explain everything, but the major components that we normally see as part of DevOps. So the major part is continuous integration and continuous delivery, like all you know. It sounds similar, but there's some small difference, or there are some difference between these two terms. Continuous integration means the code that developers are continuously developing, they are going to constantly merge that to a code repository. And once you're merging these changes, there might be some automated actions happening at the backend, which is to basically validate the code you submitted. There might be some test classes running as part of this. So this process of continuously integrating your code to repository is called continuous integration. Once you are checking in your changes to a particular repository, it can be GitHub, it can be GitLab, it can be Bitbucket, any kind of repository you might be using. But once it is checked in, there might be additional process to deploy whatever you committed to one of your environment. So that process of deploying and keeping multiple environments in sync with the latest changes, that process is called continuous delivery. And in addition to these two processes, there might be other services set up in the small services which are usable to complete the process. And also there might be communication and collaboration system also in place to complete the entire process. Like if something is failing in your DevOps process, or when a deployment is getting failed, you might need to inform someone that, or you might need to inform the submitter that the current deployment got failed and you might need to look into the details. So all these things are part of the complete DevOps process. So why we need to have DevOps? When we started with Salesforce, it's not with the other technologies, because I started my career as a Java developer. During that time also, we were using code repository to check in. But after some time, when I moved to Salesforce, Salesforce was not having that practice of utilization of a repository, because everything is in cloud, right? Whatever you are developing, it is directly in your environment itself. You don't need a separate process to deploy your changes. But later, when the environment actually when the environment is growing, when you are having more and more developers getting involved in the development activities, there can be conflicts. Like, two users might be working on the same component, so there can be conflicts. So because of all this reason, the DevOps process was getting a mandatory one for all the project development. So what are some of the advantages of this? Like I mentioned, it actually gives us better collaboration between different developers and different teams. Like if someone else is also working on your component, when you are checking in, you are actually going to get a conflict if it is in the same branch, and you are immediately getting notified on the issues. Also, when you have a process in place, when you are deploying something to a particular repository, automatically you can have set up, or you can have automated script which is going to deploy your changes to other environments or sandboxes. So it also helps to keep different environments in sync. And the deployment process is faster with an automated process. Otherwise, you might need to manually implement the changes in one environment, and you might be using a change set or an deployment tool. Or sometimes you will be using even manual configuration. If it is a simple configuration things, you might need to do it manually in different environments. When you have a DevOps process in place, it's getting automated. Everything is going to get deployed automatically, whichever component is available as part of your metadata. And the other advantage is that the retrofit process becoming easy. Retrofit process means there might be multiple teams working on the same environment. They might be working on multiple projects. One team might be working on the sales process. One team might be working on the marketing side of that, like the lead creation or campaigning. Some people might be working on the community side. And the release cycle might not be the same. So when we are having some changes for the some sales process changes for one team, and some other team who's working on the community, they might be using another environment. So when the sales process changes are in production, we also need to make sure that all the below sandboxes are getting reflected with the latest changes from production. So you can have that process also set up as part of your DevOps. That is another advantage, so that it will be automated and you don't need to manually go and deploy or sync each and every environment. There are additional issues like conflict resolution and all, but if you have a proper tool in place, even the conflict resolution is going to be easy. Other advantage is that it is going to improve the code quality through automated code scanning and testing. So in the traditional way, whenever we are completing with some kind of changes, you will be having manual review in place. That is, an architect or a dev lead will be reviewing your code and he will be suggesting changes. So DevOps process can add one more level of quality to that by having automated process in place. For example, there are multiple code scanning tools available in the market like PMT or code scanner or checkmarks. There are multiple tools like that. Some for the code quality, some for the security scanning. So in the current DevOps process, you will be able to include this scanning process also. So as soon as you check in, it is going to scan the components that you, and it is going to give you some details, or if there are issues, it is going to throw that error to you so that you will be able to go ahead and fix, and you will be having a better quality code in place. Later, I will show you a process when we are demoing. I will show you like how PMT I have included as part of the DevOps process and how it is doing the automated scanning. And the rollback process also, it's going to make easy. So how the rollback process will be easy? Normally, I mean, the chances of rollback will be very limited, and almost all the time we are expecting, like whenever we are having a production release, it is not going to fail. But in some scenarios, when you are deploying to production, there can be some unexpected issues because of which you need to roll back. So when you are having a code repository, the advantage is that always it is going to keep a history of your changes. And you can always go back to a particular stage of your branch, and you can deploy that to production directly. So that is another advantage with DevOps process. Now, since we have covered some top level things, we are going to see the basics of GitHub Actions. GitHub Actions, okay, like there are multiple tools available in the market. Like there are Salesforce specific tools like Copado, Flosum, or there can be other tools like AutoRabbit, or you can build your own solution. So GitHub Action, using GitHub Actions, you will be able to build your own solution. So one advantage with this approach is that you don't need to pay additional license to get a tool, but you can build your own tool by the way like you need. So that's the advantage with GitHub Actions. And if you have a GitHub license, you will be able to create your own rules in place. So this is basic building block of GitHub Action. Everything will be based on event. So what do you mean by an event? Event is nothing but a specific activity into the repository that is going to trigger something to run, which we have automated. For example, you are going to check in something to the repository. That is an event. A push, a pull, or once you checked in something, most of the time the development will not be happening in the main branch. So the first step of your GitHub or DevOps implementation is defining or confirming your environment strategy and branching strategy. I'm not going to the details, but you will have a branching strategy in place where developers might be using their own branches. And once the development is happening, they will be checking in the changes to their own feature branches. So at that moment, we can actually execute some kind of actions like validation, PMT scanning. So each of this process, the check-in, or you might be in GitHub Tables, we have got pull request. Pull request means you can generate a pull request, your changes from feature branch to the main branch or to some other branch. At that moment, you can add some reviewers. I will show that later. You can add a reviewer to review your component, and once the reviewer is approving, then only the merge is going to actually happen. So even the pull request creation or the merging, everything is event within GitHub Action. So on top, then you can see workflow 1, workflow end like that. So each of the workflow defines a set of actions that will be getting executed on a particular event. For example, when I am checking in code to my repository, I want to run PMT scan. Also, I need to create a pull request to merge my changes from a feature branch to main branch. So we are talking about two actions. So these actions I can club together as a workflow, which is going to be a YAML file, a script-based file that I will show later. And under each of that, there will be runners. Runner means the script that we are developing, it is going to get executed in a virtual system, not in our own machine. It can be a Linux-based system or it can be a Windows system. So GitHub is going to automatically allocate that system for you and it is going to get executed at that point only. So it's called runners. And under each runner, we will have specific job getting executed. That is corresponding to each of the job. Job is a specific action. For example, if I have two actions, one is like PMT scanning, second is generated creation of automated pull request. So first job is PMT scanning and second job is pull request creation. Handle as separate jobs, and for each of the job there will be a runner. The advantage here is that under each of the job there will be multiple steps that or actions that will be getting executed. Later I will show you like how it looks like, but all the steps will be clubbed together as part of a single job, and that will be getting executed under the same runner. That is the advantage with a job process. So similar to that, once the pull request is getting approved, there might be a second set of action that is going to get executed. That is the next workflow file. And for that, there will be a separate runner, separate jobs defined, and separate steps defined for that. This is that overall view of GitHub action. So again, I basically explained it from a high level. Workflow means it's a configure automated process. Like I mentioned, if you are checking in something, there should be a set of actions to be executed. That is called workflow, and it is defined as a YAML file, which is script based. And even there's something that we are executing, that's a developer, either check-in process or a pull request approval by a reviewer. All those are events. Jobs are a set of steps in a particular workflow. For example, if you want to execute a PMT scan, that PMT scan operation can be a particular job, and that will be having multiple steps associated with each of the job. Action is something which is getting executed. It's a custom application. Later, I will show you where you will be able to see actions. And runner, like I mentioned, is a server that runs the specific workflow that we are triggering. So since we have seen the high-level components of GitHub Actions, let us see that in action actually. For that, this is a flow that I am trying to implement or trying to demo. Our process is like this. A developer is doing development locally, and he is checking in his code to his own feature branch. So this is going to be a manual process. Once he is checking in his changes at the backend, or in the DevOps process, we want to execute the PMT scan. And if the PMT scan is success, we need to create a pull request. These two are automated actions when the developer is checking in his changes. And on pull request, that is, if someone is that is when the pull request is getting created automatically, there is another set of operations that we need to do. That is to verify that the components the developer is checked in is going to work as expected. There is going to be a new scratch-out creation and deploy your changes, or deploy your changes to scratch-out to verify that everything is working expected. So this flow, the scratch-out creation and deploying, so Salesforce internally using GitHub Actions to execute all their operations. So if you go to any of the Salesforce lab library files or projects, you can see the similar kind of setup there. Later, I am going to share the link so you can also once take a look at like how it is implemented. So like I mentioned, on a pull request creation to verify that the components are not going to fail when you are actually going to deploy that to a environment, an additional step is taken, that is creation of a scratch-out, deploy your changes there, run test classes there, and make sure everything is working fine. So once this operation is someone is going to manually go and approve the pull request. Once it is approved, the next automated job should deploy these changes to another environment. It can be a sandbox or it can be a production. But for demo purpose, I will be deploying these changes to another environment itself, another developer edition itself. Now, let me show you the details. So this is one of my dev repository called DevOps Trial. And all our GitHub workflows that we are going to develop will be available under this repository called GitHub/workflows. So if you open this, you can see there are a set of YAML files I created. And once you create, you will have an option to either execute this manually or automatically execute this. All the details will be mentioned within this file itself. And once it is scheduled, right, in actions, you will be able to see those. So you can see the first one. So that means this particular action is active, push to feature. That is, I am going to execute a set of operations when I am pushing something to the feature branch. And you will be able to disable a particular workflow also by clicking here like disable workflow. Now, let me go back to, okay. So I hope you know all the basic steps. I don't have any other tools getting used. So I am just directly trying to get the details from my Git repository to my Visual Studio Code. And you can get the URL from here. So I'm just copying the link of my GitHub repository. Let me just choose a folder in which I will be able to, okay. So I just selected a local repository in which all the changes will be available. So what it is doing, I hope you know the basic process. When you are connecting to a repository from your local Visual Studio Code, it is trying to fetch all the components from that particular folder. So when I choose option open, now what is going to happen? The remote repository components will be copied over to my local repository. So you can see all the components available in the remote is available here. This is a very simple project which I have already in my repository, and I collected details. You can see like this is my master branch. So I connected directly to the master branch and all my details will be here. It is still syncing. So just, yeah. So it's connected and you can see it is connected to master branch. Now what next step you can do? Like I mentioned, normally in the development process, you are never going to develop something directly on the master branch. Instead, what we are going to do, each of the developers should actually create his own feature branches and do the development there. For that purpose, let us create a branch. And let me put the name as demo branch. So now when I am creating a branch, it is getting created locally, right? You can see now automatically it got switched to demo branch. And I'm going to do an additional step here. Basically, I should get an option to push this. Let me check. Or let me publish this branch. Meaning now I am pushing this branch from my local to the remote. So let us go and verify. It should be available there. The sync didn't happen, it seems. Give me a minute. This kind of issues always happens during the demo. So 5 branches. Yeah, it got synced already. So you can see the demo branch is the current feature branch that I created locally. Now, I'm going to modify one Apex class only. And once you make changes, normally class development we might be doing using Visual Force code itself, and you need to deploy that your environment. For that, let me connect to my default org. I'm going to connect to my developer edition only. And let me call it as I hope you are somewhat familiar with Visual Studio Code and the normal DX commands that are available. So I'm going to connect to my demo environment. I don't exactly remember the password, so let me give it a try. Okay, that got authorized. That means your current repository or your current Visual Studio repository is connected to my dev, which is my environment. Now, that we are going to do is modify your class. But before doing anything, let us go back to my code and see what this file is going to do. So what I am expecting in my flow is that whenever I change something and I deploy that to my demo branch, which is my development branch, automatically the PMT scanning should happen and it should create a pull request also automatically. That is what I'm looking for. For that, this is the file that I have created. At the top, this is the look and feel of a particular YAML file. So you will be having the name of the file mentioned here. And here, there's a command called on. On, you are going to mention on which all events this particular file needs to get executed. So I am going to get execute this particular YAML file only when I am doing a push operation. That is whenever I am checking in something to this repository, I want to execute the remaining operation. And also you can mention this should get executed on which branch. So I created a demo branch. That's why I mentioned demo branch. You can mention more than one branches also here. For example, like, or you can mention a pattern. Normally, the feature branches will be getting started with feature / the user story number. That's a normal practice. In that case, you can mention it as feature / the asterisk, so that automatically all the feature branches changes will be getting executed by this particular file. That is the event details. And here onwards, you will be having the jobs. Like I mentioned, whenever I'm getting or checking in my components, I need to execute two operations. That's why I have got two actions here. One is PMT run, and the second one is automatically create a pull request. So this is not a normal operation, I guess. Normally, the pull request creation will be manual. Just for a demo purpose, since I would like to show you two different jobs, I created this automating pull request also. So the first one is PMT scan. And here you will be able to mention which is your server. It can be Ubuntu or it can be Windows. You can mention whichever system you want. And it is the server. It is not your local, right? So you can mention anything. So it is currently on Ubuntu latest. And also, first what you need to do is, into that particular server, you need to check out all your components. So there is a standard action available for that, which is called checkout. So I am consuming that. And this is one step. So the next step is the PMT installation. That is, in the remote server, the PMT might not be available. So you need to first install the PMT related components. And then you can call an action to run the PMT. But to run this PMT, you should have the rule set configured somewhere. So it's already available in my local. And when they are actually checking it out, they will be getting those details. I can show you that. So you can see there's a PMT folder, and inside the PMT folder, all the rule sets are available. You can see, and you will be able to add additional rules also that you want to get executed whenever some check-in process is happening. Okay, now back to the file. This is the first operation. So it is going to automatically execute the PMT scanning for the components that you are checked in. That is the first job. Now the second job is a pull request creation. Pull request means you want to merge the current checked in changes to your master branch. That is, currently we are in demo branch. From demo branch, it should be merged to your master branch. That is the for that only you will be creating the pull request. So I'm trying to automate these two. Again, here the steps are almost the same. You are checking out the repository to the server, and this is operation using by which you will be able to create a pull request. Now, in Salesforce, we have got App Exchange, right? Where you will be able to utilize some commonly available solutions, and you can install it into your Salesforce org and you can utilize that. Similar to that, uh, GitHub is also having a marketplace from where you will be able to utilize some of the commonly available functions or services. So for pull request creation, similar to this, I'm using a publicly available method. And if that needs to be executed, you need to have GitHub tokens also. So GitHub token, I think it's optional, but I used it for a specific purpose because something was not working properly and it asked for a token. So you will be able to generate your own token from repository that is here. Click on your name, and if you go to settings, there is something called developer settings. And from developer setting, you can see something called personal access token. You can generate a new token, and that particular token you will be able to utilize to set up within your GitHub Actions. So that's what this one is doing. I think since the pull request creation is automated, I have another set of actions that is going to get executed. So I want to quickly explain that file also. For that, I have got another file called handle pull request feature. So what it is going to do, it's going to get executed on the master branch. Meaning, whenever we have a new pull request getting created to master branch, we are going to run a set of jobs. The first one is same, which is going to check out your code to the GitHub Action Execution Server. Install PMD, it's again going to actually do one more validation. Actually, you can omit this, I just added. But basically what I'm going to do is a scratch or test. That means you are going to check out your code. And if we need to create a scratch org, you should have the Salesforce CLI up and running in that server. So for that, you will be then executing your installation of Salesforce CLI. And if you need to create a scratch org, I hope you're familiar with what is scratch org. Basically, it's a feature provided by Salesforce where it's a short-term period or that you will be able to create maximum validation can be up to 30 days, and you can have your small developments work happening there. And here it is you getting used in another sense, that is just for validating the component that you are checked in. But if you need to create a scratch org, you need to have a dev hub, and also you need to create an auth URL. Auth URL, how you can generate, there is a step. So that file also, that link also I will share after the session. But once the auth URL is generated, it's an SFDX command using by which you will be able to generate the auth URL. Once that auth URL is generated, you can basically set that also as part of your repository. And let me go back to my repository. And here again, you can see the settings. In settings, there is something called secrets. In secret is where you are going to set up all the repository secret. For example, you can see I have got these two, like dev hub. This is my source environment to which currently I'm connected and I'm doing development. And this is dev hub instance also, from which I'm going to spin up a scratch org for verification purpose. So this is the auth URL for that. And this is the destination that we are going to which environment you are going to deploy. You will be able to easily create a new repository secret by clicking on here and entering your name and entering the value. Now back to the code again. So you are going to create a scratch org, and for creating the scratch org, there are some additional checkings to verify that the auth URL is correctly configured within your repository. If that is true, you are going to create a scratch org, and you might be very familiar with this command like SFDX force or create scratch org definition and the day validity and all. So we will be using the SFDX command only to create the scratch org. And you will be using the standard for source push to push your current component details to the scratcher that you are newly created. Once it is pushed, you will be running all the Apex test classes. And there are some additional operations to delete the temporary scratcher that you have created. That are the additional steps that we are going to do as part of this. So when you are checking in your code to this particular branch, these are the set of operations that we need to execute. So now let us see that in action. Let me open one of the class that I am having, which is called account list. Just for test purpose, I'm going to modify a comment only. Something like what's demo. I'm just adding. I'm not actually doing any kind of code changes because I guess I'm using this for something else also. So normally once you have changed something here, what you will be doing? You will be deploying this to your org. So now it is getting deployed. Once it is success, we can push this to the remote repository. So you can see the changes. I'm going to stage this. This one is something else. So I'm just ignoring the other file I am having. Since it is staged, so some people will be using the commands directly because they will be very familiar with, or you will be able to use it directly from the UI also. So I'm just using commit staged, and you can do some kind of commit message. Sometimes when you have Jira integration and all, people will be expecting you to actually mention the story number like 1162, some value you will be able to mention, and probably a description. So you have committed, and now you will be able to push your changes. You can either press sync or you can push it, whatever it is. So now what is going to happen? The changes you have made locally, it is going to get pushed to the remote repository. Let us, you can see the message here that demo branch had recent pushes less than 1 minute. And if you open the file directly from here, we can verify that if that, yeah, you can see the comment already. So the change that we just made, it is synced in already. You can see the DevOps demo. Now, where you can go ahead and verify that the actions are happening. For that, you can go to this tab called Actions, and you can see the first one got completed already, and the second action is getting executed. So let me open the action which is completed already. This was the story number we mentioned. So like I mentioned, once we check in something to the repository, we need to execute two options. One is the PMT run, and one is create pull request. So the PMT run, if that runs successfully without any error, you can see this check mark here. Similarly, if any of the step is failing, you will be getting that into mark. Otherwise, it will be success. And you will be able to open this, and you can see the additional details here, like whatever steps got installed as executed as part of each of the steps. Those details you will be able to see here. And if there are some failures, you can see all those details here. And pull request also, you can see the additional details. You can go ahead and verify everything here. But to make sure like the pull request actually got created, what you can do is there is a pull request tab available. You can go there and you can see that there is an automatic pull request that got created. When you open the pull request, you can see the details. The pull request is from the demo branch where I did the development, and it is to check in the components to master. And there is one more action, right? When the pull request is getting created, there is one more action that is getting executed on the pull request creation. That is the PMT run and scratch or test. PMT run, since we have already done, we can ignore. But the scratch or test will be doing, you can see all the steps here. It is going to get the GitHub URL related. No, it is actually going to check out the code first, then locally not locally into the remote server where actually this is getting executed. It is going to install the Salesforce CLI, get the details of the secret of auth URL of your dev hub, Then we need to authenticate that, create a scratch org, push your changes there, then execute run test. Then we are going to execute some deletion activities to delete the scratch org. So you can see it got till that, at this point, it is success. That is automatically a pull request got created. Now someone should go ahead and actually approve this pull request. But before approving the pull request, let us go and see what are the actions that are going to get executed once we have this pull request approved. For that, I have got another file or another action called deploy to SCC. This is my file. So this is going to happen on a merge operation, but merging also mean the system or GitHub is automatically treating it as a push operation only. And so it is on push to master branch. That is when you are approving, basically the changes are going to get merged to your master branch. So it is on master branch, and these steps you should be familiar by now. Like, we are specifying the server, and we are checking in the code to that particular server, and we are now getting the auth URL corresponding to the destination org. So there is a org called ACC to which I am going to actually deploy the changes. So this is to authenticate that particular environment to which that we want to deploy, and this for source deploy, the standard SFDX command to deploy. This is my username, and you can specify which branch you want to deploy. If it is entire directory, you can give the entire directory, or if you just want to deploy only the specific files, you can provide a manifest file also. It's up to you how you would like to configure this. So this is what we are going to do. Now let me go ahead and merge this. So once the merging is happening, I'm just confirming. It's not the standard process, because since this is my own development repository, I don't have any other user available, so I cannot assign a reviewer. Basically, this will be done by a reviewer who will be logging in and approving the request. That's a standard process of pull request. Now I merged this already. So let us go to actions and see if we are having something getting executed. So we have this action merging of pull request, which is in progress, and the authentication got completed already, and the deployment is happening. You will be able to verify everything here already. So the authentication happened, and also the push to second environment is also success. You can see all the components got deployed successfully to the second environment. So maybe later we can, because checking the time, I'm not going to log into that org and show you the details, but the deployment is success. So this was a simple flow of DevOps using GitHub Action. If you have any questions, please share on the chat. We can take after this. Just some quick details also on the advantages of this approach. I would say, like, if you have a high-level understanding of YAML file, how to set up, you can implement this easily. Basically, before I start working on this, my experience with YAML file was almost zero. I have just seen the details. I haven't implemented anything. So it took just 2 to 3 days for me to understand and implement this flow. So it's not very difficult for us to implement. And like I mentioned, there are public actions available in marketplace which you will be able to utilize. Even for SFDX specific public actions, I was able to see that others have created that probably you will be able to utilize. And the execution is faster, like you have seen. The 3 components deployment doesn't look much took much time, right? And when you are having more components, and it depends upon, you are going to do a delta deployment versus full deployment. Full deployment might consume more time, and it also depends on the number of test classes that you need to run. All this, the deployment time depends on all this, but compared to other platforms like GitLab, GitHub is comparatively faster. And you can also have condition-based execution also. For example, in the previous case, if the PMD validation was a failure, I can stop my pull request creation. So those kind of condition-based action also you will be able to do. And Jira integration is also possible. And the other things are, like, if you want to have test test scripts like Selenium-based scripting or some other automated scripting you want to execute as part of this process, you can integrate that also. I guess those are through some webhooks. Webhook actions are available. I have never tried it out, but it is really feasible. But also there are some considerations. Like I mentioned, we might need help from people who are good with Git operations, and also they should have some understanding on Salesforce metadata. This is on this is about the people who are the implementers of this particular process, not the consumers. Like developers, they don't need to understand everything, but the people who are implementing this, if he can be a proper DevOps person, that will be better. And the script maintenance is needed. Like whenever we are having additional branches or additional team, we might need to make changes to have additional process in place. And retrofit activities. So this is something that we are currently experiencing. That is, when you want to do the retrofit, there might be conflicts. That is, two environments, they might be having same profile changes. And when you are trying to retrofit the production changes back to your environment through GitHub Action, it will be showing you conflict directly in GitHub, but the resolution might not be straightforward. You need to have some kind of a Git operation understanding to solve those files. And the other thing is, it's very suitable for the development team who are very familiar with Visual Studio or the other tools like that. But for support or admin team, it might be a bit difficult to handle this tool compared to tools like Copado or Flowsum, where it looks like almost Salesforce, right? You can do anything from the UI itself. So these are some resources. I have got a blog post which is actually detailing all the details, with all the links and examples. You can take a look at this if you have got some questions. And also there are some additional links mentioned here that I referred to create all the script. I can share all this at the end. That's it. If there are additional questions, we can take that now.
Yep, that's great session, Meera. I can see few questions raised in the Q&A. Meera,
Okay.
are you able to see the Q&A?
I'm just opening it. Okay. Yes. Yeah, there are many questions. Okay. The run zone, like I mentioned, you will be able to refer, or you can mention which is the server in which it will be getting executed. That's what run zone specifies. I can share let me right away share you the link, which actually details all these different parameters, like what does it mean. There is a documentation available directly in GitHub, the GitHub link itself, and there's a quick start, which is going to give us more details about how you can configure this one, what each of the parameters tell us. All those details are available here. Okay, why do you need to do the installation of PMT? Like even if the file is in the GitHub, the execution is going to happen in a remote server. That remote server is what we are specifying using the run as. It can be an Ubuntu server or it can be a Windows server. We can mention that, and that will be allocated by GitHub itself. We don't have any control on that. And that is a server. So whatever you need to install, which needs to execute your actions, that should be installed in that server. That's why we are having PMT installation, Salesforce CLA installation, all those installation as the first step before you execute any of our own operation.
Sorry, Meera, to interrupt. For this one, right? If we have a dedicated server, then we don't need to run or install every time. Is it correct?
I'm not 100% sure, because this is the approach that we are following and that I have seen everywhere. If you can have a dedicated server by your own, I guess if you are utilizing an on-premise GitHub, it is feasible. Yes.
Yeah. Okay.
Yeah. This runs actions run on a user's no specific context. This is purely based on the token that we are configuring. And normally the deployment process, whatever it is, like, if it is GitHub or Copado or the normal execution, normally for production deployment, we will be utilizing a dedicated deployment user, right? So even in our projects, we have a dedicated user, and the auth URL will be getting generated using that particular user, so that it is not going to be any other users, it is going to be the deployment users' credentials. While spinning up Scratch against which the new changes are validated, will it have the dependent custom elements that were deployed in last release? Yeah, so that's again a question related to your governance process. Like, are you going to do a delta deployment or full deployment? We are always doing a full deployment. So like Scratch.org is always going to have all the components that you need, but that have got other issues also. Like, Scratch.org has got always limitations. Like if you have got too many components, like more than 10K components, sometimes you won't be able to do a full deployment to Scratch.org. So that point, what you normally do, you will be creating small packages, or it can be unlocked deployment, unlocked packages specific to a particular feature, and you are going to install that unlocked package first, then you deploy your components. So it is the way you are going to define your governance strategy. You will be able to handle that. How GitHub Actions handle the two-factor authentication? I'm not very clear with that question, because I'm not sure why we need two-factor authentication for this scenario, or that might be specific to the deployment process, right? So basically, I have never seen people setting up two-factor authentication for GitHub process. Does PMT rule set needs and other authentication? If it is PMT, that does not need any other current, because that rule you have defined as part of your own package. It's available there. In that case, you don't need any additional authentication. Suppose we have chain of environments from dev to prod. If any, in that case, what would be the best approach? Should we keep every org has movement, has separate branch, or keeping same branch segregate? Yeah. So this is a branching related question, I guess. So there is no specific rule when it comes to the branching strategy, I guess. It depends upon your org, like, and the number of developers you have, because we have seen everything. Like, some organizations, they use Scratch.org based development, and in the Scratch.org based development, each developer will be using their own development branches. So once the development is done, they will be checking into the development branch. From this development developer branch, they will be checking into a common dev branch. At that moment only, you are going to see all the conflicts. So when you have too many developers, some organizations will do this approach, or instead of that, for all the developers, we can have a single development branch. From that, so all are going to check into the same development branch, and so that you can have the early conflict detection at that place. Because when if someone else is also modifying the same component, if the same branch, when you are checking in, you are going to get a conflict that someone else has modified. So you need to get those changes first to your local before you merge your changes. So that is one advantage with having a common dev branch for development. And then you can have additional branches for QA, UAT, and sometimes, or we keep like release specific branches also before going to the master branch. Most of the time, your master is going to be the production copy. That means whatever components is there in production, only those details will be there in your master branch. But the other changes, probably you might be having a specific branch to which you will be merging, and that release branch might be getting used for production deployment. Once the production deployment is success, then only you are going to merge those changes back to your main or master branch. I hope I have given an overview, but the branching strategy is very complex. It depends upon how your team is structured, what is your environment strategy. How rollbacks action will be execution in this process. Again, it's not automated, or rollback with GitHub Actions, it's not automated. You need to have a separate destructive package in place. The first step probably might be, go back to a previous version of your GitHub branch, deploy that to production so that the existing components will get rolled back with the correct changes. But you might be still having new components which got added. that cannot be rolled back directly, right? You need to have the destructive package in place. So you will be deploying that destructive changes first so that the new components will be removed. So it is going to be a step-by-step process, not a straightforward one. And okay, after doing the pull request immediately, it is deploying. What about other team also working on same class? We need to check code, compare and merge it before commit to master branch. Yeah, like I mentioned, it's again depending on your branching strategy. If all the developers are going to check in to the dev branch itself, now I execute it as feature branch, but suppose if it's a dev branch, as soon as you execute this check-in process, you are going to see the conflict. You won't be able to check in itself. You have to first resolve the conflict, then only you can check in to the dev branch. So it purely depends on your branching strategy. Different client does have different coverage limit for test classes. Where do we set it? So it's part of your, again, the your file or your YAML file, where you will be able to have additional script to mention if the test coverage percentage is 90% only, then go forward with that. So I saw there is something called secrets, right? So secret is the place where you will be able to set up variables, and later you will be able to change the values based on that. Similar to something like custom label or custom metadata we use. Did I miss anything else? I think I lost some of those, Shaktivel. But I can see one more question, like, why do you need to do a PMD installation? I think I mentioned that already. Like, since it's going to get executed in a separate server, we need to install that. And that is a temporary instance that is getting created for this execution. The,
Yeah, right. I think you covered most of the Q&A, Meera, and also we are running out of the time. Yeah, um, I think we can wind up the Q&A. Guys, if you have any other questions, please reach out to Meera in the social channels. She is
yes.
actively available to answer all your questions. Yeah. Once again, thank you, Meera. It was a very informative, altogether end-to-end walkthrough, and interestingly, you showed all the step-by-step guide and then demo, and hopefully this helpful to everyone. And even you covered most of the Q&A from the audience as well.
Yeah.
Hopefully everyone liked it. And once again, thank you for sharing your knowledge to the Trailblazer community group. Let me share my screen and then I will update few things from my end.